Hello guys, today let's solve this lead code question which is validate binary search tree which is part of the medium tag. So let's read the problem description first and try to understand the question. So what they're saying is given the root of a binary tree, determine if it is a valid binary search tree or not, right? So a valid binary search tree is defined as follows. The left subtree of a node contains only nodes with keys strictly less than the node's key. The right subtree of a node contains only nodes with keys strictly greater than the node's key. Both left and right subtrees must also be binary search trees. So yeah, it's a pretty straightforward question. So let's try to understand this with examples here. So the thing is they have given a binary tree. So what's a binary tree? Binary tree always has like two nodes for every root. So they wanted us to check if that binary tree is a valid binary search tree or not. So what's a valid binary search tree? The node that's present on the left side of the root will always have value less than root, and the node's value that's present on the right side of the root will always have value which is greater than the root. So here 1 is less than 2 and 3 is greater than 2. So that is what a valid binary search tree is. So even in this example you can see 1 is less than 5, and you can see 4 is this is 4 is lesser than 5. So ideally this node is supposed to be greater than the root node, but here since 4 is less than 5, this is not a valid binary search tree, so that's why we return false. So this is a pretty straightforward question. So how are we going to solve this? So before jumping into the code, let's try to think of an intuition. So if I want to know if this tree is a valid binary search tree or not, I would have to definitely traverse this binary tree first, right? So how am I planning to traverse this binary tree? Like there are three main ways with which you can traverse a binary tree. They are called as in-order traversal, pre-order traversal, and post-order traversal. So what do these traversal techniques mean? So if you talk about in-order traversal, let's try to write this out. So for in-order traversal, you always print the left node first, then the root node, then the right node. For pre-order traversal, For pre-order traversal, you always print the root node first, then the left node, then the right node, right? So for post-order traversal, you always print the left node first, right node first, and then the root node. So these are three main traversal techniques that we use for traversing a binary tree. For this particular question, we are going to use in-order traversal. So why am I going to use in-order traversal? So the intuition goes like this. So whenever you do an in-order traversal of a binary search tree, then the numbers are always printed in the ascending order, sorted ascending order. Okay, what do I mean by that? Let's take this example one. So if I'm doing an in-order traversal and printing the values of this binary tree, the numbers would be printed something like this: 1, 2, and 3. All right. So you can see 1, 2, and 3 is is perfectly sorted in ascending order. So I can confidently say that this binary tree is a binary search tree, valid binary search tree. Whereas if you try to print this example 2, it's not going to print you in an ascending order. So it's going to print 1, then it's going to print 5, then it's going to print 3, then 4, and then 6, right? Because it always prints left, then root, and then right, correct? So it prints 1, 5, then it prints 3, 4, and 6. You guys can clearly see that this is not in the perfectly sorted ascending order, right? So we will straight away return false. So that's the intuition, guys. So the core logic is this: whenever you're doing an in order traversal of a binary search tree, the numbers are always printed in the ascending order. So in this case, if you're not seeing the numbers in sorted ascending order, then it is clearly not a binary search tree. So that's the intuition behind solving this problem. So now let's try to code this out. So first let me try to code the traversal method. So private void, let me name that as in order traversal, and this is tree node, and first I need to have a base condition. So every recursive call needs a base condition. So here the base condition would be like if node equals null, I'm just going to return, right? So there's nothing to do if my node is null. So in order traversal, you print left, then you go root, then you go right. So how am I going to do that? So I'm going to make a recursive call here. So I do in order traversal, and I call the and I pass in the nodes left, and this is where I'm gonna get the root. Let's come back to the root logic in just a bit, and now I call the right. So this is the basic skeleton of in-order traversal. You print the left node, then you go to the root, then you go to the right node, right? So that's the in-order traversal. So now how am I going to, fetch these numbers 1, 2, 3, 1, 5, 3, 4, 6, right? So I'm going to do something like this. I'm going to have a helper variable, let's say private integer priv, and I'll assign this to null. I'll tell you why I need this helper variable, right? So the thing is, whenever you are having this number, you always check the current number with your previous number, right? For example, so let's say if I'm in number 2, I always check if my current number is greater than the previous number. So here 2 is greater than 1. I'm good. And when I move to 3, I check 3 with my previous number, which is 2. So 3 is greater than 2. I'm good. So the thing is, whenever I am iterating or whenever I'm going through the traversing through the binary tree, I should always check my current value with my previous value. And I have to make sure my current value is always greater than the previous value. If it is not greater, then that's not a valid binary search tree. So I need a variable to hold the previous value. That's why I'm using this helper variable priv, right? So for the first time, whenever you're traversing, this prev value is null. So we'll have a null check here. I'll say if prev is not equal to null, I'm gonna do something. But for the first time, prev is null. If my prev is null, I'm just gonna do prev equals node dot val, right? So first time you get one, so prev is null, so node dot value is one, and it gets assigned to prev. And when you come to the second call, second traversing call, now you have the value as 2. Now my priv is not null anymore because my priv is assigned with 1 already. Now I'm gonna check 2 with my previous value, which is 1, and I'm going to make sure if 2 is lesser or greater than 1. If it is lesser than 1, then it's not a valid BST. If it is greater than 1, it is good, and I move forward. So I'm gonna do that comparison now. So what I'm going to do here is something like this. If my current val, which is node.val, if it is lesser or equal, be careful of this condition, guys. It should always be greater. Even if it is equal, it is not a valid binary search tree in this case. So that's why I'm using a lesser or equal to operator here. Is lesser or equal to priv. This is an invalid condition, right? So node.val should always be greater than prev, but if node.val is less than or equal to prev, then this is a invalid condition. So I need to break out of this traversal and I have to return it immediately. Because I don't need to traverse further. I know that this guy is wrong. For example, when I'm at 4, I know 4 is less than 5. I know that this is not a valid binary search tree at this point itself. So I don't need to, traverse further. I can simply break out earlier and return the response. So how can I do that is I can have some boolean variable. I can say like is valid equals true, and I can say is valid equals false here, right? So whenever this condition is met, then I know that the binary tree is not valid. So I'll just do is valid as false. Simple, right? And what I'll just do, I'll just check this here. If false, don't even do the traversal technique, right? If it is false, whenever this gets assigned to false, I don't even need to call my recursive calls. I can just simply break out of the loop. So that's the intuition. So let's call this method from the main method. I'll just do in order traversal. I'll just pass in node, and finally I can just return is valid, right? Simple. So let's try to run this. Okay, there is a compilation error. Let's see what is it. Is valid in order traversal. Okay, I forgot the if statement here. My bad. Okay, okay. There is one more typo. It's tree node, not tree node. Hmm, one more. This is not node. This is root. Okay. So many, so many typos. I'm sorry. All right. Our code compiles. It works fine. Let's try to submit this. Mhm. It works. So that's it, guys. This is the logic. Please let me know what you think. I'll catch you in one more video. Thank you. Bye bye.